So, hello guys, in this video we are going to solve a auxiliary differential equation which has a imaginary roots. So, we have here an example, d raised to 4 plus 18d squared plus 81 times y is equals to 0. So, in getting the roots of this differential equation, we will change d into m. So, this will be m raised to 4 plus 18m squared plus 81 is equals to 0. So, to get the roots, we will factor this polynomial out. So, this will be m squared plus 9 times m squared plus 9 is equals to 0. So, we will get the value of m here. M squared is equals to negative 9. And to get the value of m, square root both sides. Square both sides. Or get the square root of both sides. So, m is equals to positive and negative 3i. So, they have both the same root. So, this will be twice. So, the general solution for this differential equation will be y is equals to c1 plus c2x since it has the same values of roots times cosine 3x, which is the root of our equation, plus c3 plus c4x times sine 3x. So, this will be our general solution for this differential equation. And next, we have here another example, number 51. D raised to 5 plus D raised to 4 minus 7D cubed minus 11D squared minus 8D minus 12 times y is equals to 0. So, in getting the roots of this, we will first change D into m. So, this will be m raised to 5 plus m raised to 4 minus 7m cubed minus 11m squared minus 8m minus 12 is equals to 0. So, to get the roots of this equation, we will use synthetic division. So, we will, in using synthetic division, we will write down the constant of the terms in our equation. We have, in our first term, we have 1 and then positive 1, then negative 7, negative 11, negative 8, and negative 12. So, in synthetic division, we can use trial and error. So, here we will first try the positive 3. So, this will be 1, bring down 1, 1 times 3 is 3, then 1 plus 3 is 4, times 3 is positive 12. Positive 12 minus 7 will be 5. 5 times 3, 15. 15 minus 11 is 4. Times 3 is 12. 12 minus 8 is 4. Times 3 is 12. Equals to 0. Since it is equals to 0, so therefore our first root is positive 3. Next is, this will be the constant of our next equation. So, this will be m raised to, reduce the exponent into 1. So, this will be m raised to 4 plus 4m cubed plus 5m squared plus 4m plus 4 is equals to 0. And then again, we will use synthetic division. So, this will be 1, 4, 5, 4, 4. So, we will try to use negative 2. So, this will be, bring down 1. 1 times negative 2 is negative 2. 4 minus 2 is 2 times negative 2, 4. Or negative 4, then 1 times negative 2 is negative 2. This will be 2. Then negative 4 is equals to 0. So, therefore, our second root is negative 2. And then, again, we will reduce the exponent in here. So, this will be m cubed plus 2m squared plus m plus 2 is equals to 0. And we'll use again synthetic division. 1, 2, 1, 2. And we will try to use negative 2 again. So this will be 1, negative 2, 0 times 0. 1 times negative 2 is negative 2. Is equals to 0. So our third root is equals to negative 2. We already have our negatives 2. So this constant is, if we will write this into a polynomial equation, this will be m squared plus 1 is equals to 0. So if we get the value of m here, this will be, the root will be m is equals to positive negative I. Therefore, our general solution, or our third and fourth root, and our fourth and fifth root will be positive negative I. Therefore, our general solution will be y is equals to c1e raised to our first root 3x plus c2, our second and third root is just the same, so we can write this as c2 plus c3x times e raised to negative 2x plus c3 cosine x plus c4 sine x. And this will be our general solution.